Welcome. Let's talk a little bit more about divisibility and number theory. So, in number theory, division is not really something that we're going to do in case you haven't already figured this out. Instead, we're going to, and because number theory, we can't really divide because not every integer divided by another integer is still an integer. So, the division operator is out the window. Instead, we have something like this: n divides m if there is an integer k such that m equals n times k. And we write it with a bar between them. Now, this is something a little bit more. We also consider that m is divisible by n, but we usually just say that n divides m. So we say what divides it is the more common terminology. So let's just practice a little bit of the notation. So I want you to look at this for a second and think, how are these mathematical representations similar? Well, and how are they different? There's a few things. So let's just talk about this first one. M divides N. By definition, this literally means that N, the second number, equals M times K for some integer K. So that's what this first one means. This one right here is literally, both of these literally mean M divided by N. Now, there is a problem there. Sorry. I apologize. I have a cold. I'm trying to make this video with while having a cold. This may not be an integer. So there may not be an integer solution. This statement up here is actually it's actually just true or false. Either it's true or it's not. So I can write it, it's true or false. These are supposed to represent some kind of rational number, and thus we actually have a slight problem. So we have to be very, very careful we understand what the notation means. So do not do a sideways slash or over the top. You need to stack them up one on top of the other in order to get them to kind of work just right. Now let's do an example with this. So I want you to, this is to prove or provide a counterexample that if 6 divides n, then 3 divides n. So the first question is, we need to make a best guess. When you have something like this where it says provide or prove or provide a counterexample, you're making your best guess. Do you think it's true or think it's not true? So I want you to take a minute and just kind of pause and think about that. Do you think this is true or not true? Okay. Hopefully you already came with an answer. My statement is this is true. So how do we prove it? Well, like all these, we start off with something like, suppose 6 divides n. So then by definition, and this is how I write by definition, 6k equals n for some k. However, we know that 6 is equal to 3 times 2. So that means 3 times 2k is equal to n, which means that 3 times 2k is equal to n. This statement right here, by definition, 3 divides n. And there we have it. So we have to make our best guess and then try to prove it. This is kind of our way to attack this. I know this is a super short proof, and we're starting off with ones actually that are going to be really, really short and simple. We're going to get to some more complex ones later, don't worry. But we're going to start with very simple and straightforward ones. Let's do another one. So here is very similar, except if 6 divides n, then 4 divides n. Is that true or false? I want you to think about that for a second. If you assume it's false, can you come up with a counterexample? An n where 6 divides it, but 4 does not. That's what we need here. We need an n that 6 divides it and 4 does not. Well, to do that, I'll give you a counterexample. It's a very, very easy one. Let n equals 6. Then 6 divides 6. Check, we did the if part. We did the if part. But 4 does not divide 6. Now, this is the symbol we do for not divide. We just do a straight line with a slash through it. And just like that, we've proven that 4 does not divide 6, but 6 divides 6. Now, if you want to try to do this further, we can say, okay, suppose that 4k equals 6. And some different things. We can notice that there can be some different, it can be like 2 times 2k is equal to 2 times 3, because that's how this breaks out. So by definition, 2k equals 3, but that means that 3 has to be an even number, which is a contradiction, and we can get around it that way. This is going way farther than I expect you to do, but that's something if you were trying to really, really dive deep in this one. So whenever I ask you these questions for prove or provide a counterexample, all I need you to do is make a best guess and then go down that road. If you cannot find any counterexample, suppose you think it's not true, but you keep trying a lot of different options and they're not working out, then look at what's the pattern of the numbers you're looking at anyways, and does that work? In this case, you literally could have started with, let's try some ends. Let's do a 0, 6, 12, 18. How many of those does 4 divide? And quickly we would see that we have a slight problem and get a counterexample. That is usually how we attack these problems early on in the thought process. It doesn't mean that's more the advanced, but that is early on how we attack them. All right, so what you need to do now for your discussion board is handle the following problems. Suppose that n, m, and a are all integers, and a divides n. You need to show that that implies that a divides the product mn. And the good news is I'm telling you now it's a theorem. So because it's a theorem, you don't have to guess is it true or false. You already know it's true. You're trying to do it. And again, you have to do this with very general m and n. You have no clue what m, n, and a are, but you have to have it be true for any combination of m, n, and a that this works. Next, you need to show that if a divides n, then a divides n squared. This may seem fairly straightforward. Again, I'm giving you a very generalized problem because I find that this is where students struggle, is not with the give me exact numbers to work with. When we get general numbers, that's where we struggle. And lastly, I want you to attack this one. Prove or provide a counterexample that if a divides n squared, that a divides n. Try that one, and I'm really curious to see what your posts are. Let me know what questions you are. Again, sorry for getting this posted a little bit late. And I look forward to reading your discussions.